Okay, Assalamualaikum and good day to everyone. Okay, so today I will be covering chapter 7, okay, which is on the real interest rate and real interest rate parity. Okay, so in your textbook, which I uploaded in your OL, you can check chapter 7. Okay, it's under chapter 5 actually. Okay, so the focus for this chapter will be to understand what is Fisher equation. Okay, so this is the main thing. What is Fisher equation and how you prove the construct of Fisher equation and how actually you apply Fisher equation to achieve the equilibrium with regard to two countries' inflation and expected exchange rate. Okay, so let's take a look at the textbook first. So first, what is Fisher equation? Okay, so Fisher equation as the the equation. Okay, actually it derived from the well-known economist, okay, Irving Fisher, okay, whereby he developed the idea or the methodology which equates uh, real interest rate, okay, kadar upah benar or real interest rate as the uh, product of nominal minus the expected inflation. Okay, expected rate of inflation. Pi E is the expected rate of inflation. The E stands for expected. Okay, so and then if you can rewrite the equation, that gives you R, which is the real interest rate. R, which is the nominal interest rate, is the product of real plus expected rate of inflation. Okay, so the expression or the equation is very simple and straightforward. Real interest rate is the product of nominal minus expected inflation. So I think the concept of real price, okay, is quite common, okay, especially for economic students. For example, real price is the nominal price level minus the CPI index or the inflation rate. So the same goes with real inflation. Real interest rate is the product of nominal interest rate minus the expected inflation. Okay, and then that brings us to the concept of real interest parity. So we discussed what the word parity means, or similarly known as equal, okay, or similar in value. That is the word the word parity means. Okay, and then when it comes to the okay, when it comes to the two countries' rate of inflation or rate of exchange rate, okay, we can combine this. Okay, let me use my notes. Okay, much easier to follow. Okay, so basically it came from the same material from the main book. Okay, so what is real interest? What is real interest parity? Okay, so as what I mentioned just now, okay, nominal versus real. By now you should be able to distinguish between these two terms. So when it comes to the application of real interest rate, it's just taking into account inflation. Okay, but for the Fisher equation, it uses expected inflation, okay, not actual inflation. Okay, because why expected? Because when you want to calculate the real interest rate today, okay, you do not know what is the expected, what is the inflation 1 year from now. Okay, because we are talking about the real return. For example, you put your money in the bank today, okay, and you expect, let's say, to get the return 1 year from now. That's why you cannot use the interest, the inflation today, but you need to use expected inflation 1 year from now, where after 1 year, let's say you want to deposit the money after 1 year, then you want to withdraw, you want to take out your investment. So it will be what will happen 1 year from now. So that is the idea why we use expected. Okay, because when you put the money in the bank, you don't put the money today and withdraw tomorrow. So there will be no return on a short-term 1 day deposit. Okay, so for example, here a simple example: if you put, let's say, you buy a government bond, okay, for 1 year return, and the government pays, let's say, 5 years interest rate, and then inflation is expected to be 3% in the next 1 year. So your real return is basically 2%. Okay, after you take into account the inflation, the expected inflation. Okay, so for the word parity means it must involve two countries. Okay, two countries interest rate. Okay, so the word real interest parity, the condition is that the real interest rate of country A or domestic should be equal to the real interest rate of the foreign country. Okay, let's say Malaysia, and it's R star would be, let's say, the USA. Okay, so we can, why is this useful? Because we can compare. Okay, if you want to invest locally or you want to put your money overseas. And then also taking into account the changes in the inflation rate after 1 year, whether it is worthy, I mean, it is more profitable to put the money locally or you want to put the money overseas. So that is the idea of why we want to look into the concept of real interest parity. Okay. So how RIP is derived? It came from three components, basically. The Fisher equation, which we just discussed just now. They define real interest rate is the nominal minus expected inflation. And then the real purchasing power parity, this one we already learned in the previous chapters. And then also uncovered interest parity, we also learned this before in the previous chapter. So the combination of these three concepts will allow us to arrive at the equilibrium or at the final interpretation or the final equation from the Fisher equation just now. Okay, so we start with step number 1 first. R stands for the capital R without the asterisk. This is for local. R star or R asterisk is for the foreign. Okay, so the rest I think you get the idea already. So R is the real. Okay, real interest rate, sorry, nominal interest rate is the product. So this is basically we reverse the process from the original equation here. Okay, we take R to the left and the small r to the, or the nominal to the left, real interest rate to the right. Okay, so that gives us these two components or these two equations. Okay, and then what is relative purchasing power parity? So we learned this, I think, in chapter number 3, if I'm not mistaken. Okay, is the PPP or purchasing power parity, and then we have the word relative. Relative is you take into account the changes in exchange rate or the changes in inflation rate differential. Okay, so this is what we learned before. Changes in exchange rate is equivalent, okay, to the changes in inflation rate between two countries. Okay, so this is our relative purchasing power parity. The word relative stands for we are comparing changes in exchange rate to the changes in inflation between two countries. And then we also have the concept of uncovered. Okay? We have covered and uncovered. Uncovered means we do not engage in any forward contract market. For example, if you expected to receive money or to pay money to an importer or exporter, let's say 3 months from now, 6 months from now. Okay? Uncovered means the trader or the investor do not want to lock into any forward contract, so it just gamble. Okay? Gamble means whatever the rate 3 months, 6 months from now, the investor or the trader is willing to take the risk. And that is uncovered. So uncovered, we use the spot exchange rate, spot rate, the expected spot rate 1 year from now, minus the spot rate today, divide by the spot rate today. So this is basically the percentage, the changes in spot rate, okay, is equivalent to the changes in the nominal interest rate. Okay, you remember R is the nominal interest rate. Okay, so this is when we combine these three. Okay, we combine RPPP and UIP, and then that gives us to this. I mean, you need to go through the equation step by step in order to be able to understand and appreciate the process, how we arrived at the Fisher equation just now. Okay, so since both right sides are equal, okay, you can see here, this one is the changes in inflation. This one is the changes in the nominal interest rate. Okay, but the left side is equivalent. So you can take both sides here and then just, so pi minus pi star, which should be equal to R minus R star. Okay. Now substitute the Fisher equation into both R and R star. So we know that what is R and R star from the Fisher equation. Fisher equation R and R star is equivalent to this one. Okay. Originally we start from this and we bring the left to the right, right to the left. Okay. And then we end up with this one, which is the Fisher equation. So from here, you can substitute into the, once we combine 2 and 3, we get this equation, R minus R star, or nominal interest rate is changes in nominal interest rate is equivalent to the changes in, or the differential in expecting inflation. And you substitute this, you get R plus phi minus R star plus phi star equivalent to this one, and then you can stop lah. Okay, and finally you can arrive at step number 5. Okay, you can solve for this to get R equals to R star, which is the real interest rate in local country is equal to the real interest rate of the foreign country. Okay, or in other words, real interest rate equal across country. Okay, so that is how RIP is, right? I mean, you derive RIP. So this is from the symbol or from the general construct of the formula. Okay, if you plug in the values, okay, from Malaysia and the US, okay, I think you are familiar with this kind of example. We've been through this type of example before. So you need to plug in all of the relevant values into the equation, and you should be able to prove that, okay, R equals to R star, which is 2.5%. Okay, and then what if RIP doesn't hold, meaning the real interest rate between two countries does not hold? Then of course, okay, we can have these arbitrage opportunities where the country that offer the higher interest rate that will attract more investors, okay, and then the demand for the country will increase. For the demand for the current people will start depositing more money into the country that has higher interest rate, and that will lead to increase in supply of deposit, and that will eventually bring down the interest rate. So at the end of the day, okay, market will adjust and interest rate will tend to equalize between two countries in the long run. Okay, so this is what is the effect of RIP doesn't hold. So this, the concept of real interest parity should equalize between two countries, because of course you may not be able to you may find the rate is not equal between two countries. It may be in the short run, okay, due to the inflation between two countries. Okay, but eventually, okay, traders or investors who seek to get profit, okay, from arbitrage opportunities, this will cause the market to move or to adjust, and eventually equilibrium will achieve, okay, when the rate between the two countries are equal. The rate of real interest rates are equal between the two countries. Okay, so chapter 7 is quite short, okay, but even though it is very short, okay, the students struggle actually to get this part right, meaning how to develop the Fisher equation methodology, okay, from the first step until the last step, and to prove that both equations the real interest rate between two countries equalize. Okay, so this is in terms of the derivation of the formula. Okay, and another part is the application part, okay, to prove that the real interest parity works or hold between two countries. Okay, so this will be a very short lecture, but sufficient for you to cover chapter 7. And again, okay, short chapter, but application-wise it can be applied in different type of questions, numbers, and scenarios. Okay, so please do revise this thing, and as usual, you can rely on your AI buddy, okay, to upload the note and come up with different example questions, so that you should be able to understand how to apply this concept in your assignment or in your quizzes or even in your exams later on. Okay, so I end here. Thank you. Assalamualaikum and good day to all.